Okay, so we had just been speaking in the last part about this technique. If you have a single log on each side of the equation of the same base, you get to set the inputs equal. Now, what about solve log base 4 of 3x minus 1 equals 2? Now what? We can't use the technique that we just were using. It doesn't apply because you need a log on each side. And notice the right side just says 2. We don't have a log on that side. We need a log on each side of the same base. We don't even have a log on the right side. So we can't use the technique above on this problem. So now what? Well, just recall, we still have the definition of logarithm. So check this out. Log base 4 of 3x minus 1 equals 2. Check out how that's like log base b of n equals m. So the b is 4, n is 3x minus 1, m is 2. So rewrite this equation here in this format, b to the m equals n instead, and you'll have, sorry, I swapped the two sides, but n, okay, that 3x minus 1 equals 4 to the 2. That's a nice equation. So literally using the definition of logarithm, log base 4 of 3x minus 1 equals 2 turns into the equation 3x minus 1 equals 4 to the 2. Well, simplify 4 to the 2 as a 16. So you have 3x minus 1 equals 16. Add 1 to both sides, divide both sides by 3. So x equals 17 thirds. We're not done because the equation started with log, so we should check that 17 thirds is okay. In other words, is 3x minus 1 positive? Well, 3x minus 1 actually ends up simplifying to 17 minus 1, which is certainly positive. So x equals 17 thirds is a solution. So check out how the definition of logarithm was helpful here. Let's try another one. Log base 5 of 7x plus 3 equals 2. Using the definition of logarithm, this will turn into 7x plus 3 equals 5 to the 2. We'll simplify that 5 to the 2 as a 25. So 7x plus 3 equals 25. Subtract 3 on both sides. Divide by 7 on both sides. X equals 22 over 7. Now we're not done. I get that this number is positive, but that doesn't matter. It doesn't matter whether x is positive or not. We need to check if 7x plus 3 is going to be positive or not. So 7x plus 3 ends up being 7 times 22 over 7 plus 3. You know what? There's not even a minus sign in sight, so that's got to be positive without working any further. Okay, so x equals 22 over 7 is a solution. So check out how awesome the definition of logarithm was helpful in the case that the new technique wasn't helpful. The key step was to use the definition of logarithm. And in fact, just to review a thing from last time, the definition of logarithm is also useful in this kind of setting. So solving 2 to the 3x plus 1 equals 9, this, again, definition of logarithm, the thing we were just using works. It's just, earlier we were turning the log equation into an exponential equation. Now we can turn b to the m equals n into a log equation. So that's going to help, b is 2, m is 3x plus 1, n is 9, and then this ends up being 3x plus 1 equals log base 2 of 9. Subtract 1 on each side. So 3x is equal to log base 2 of 9, then a minus 1. Don't turn that into a log base 2 of 8. It's not a 9 minus 1. Okay, it's log base 2 of 9. Take a breath, then a minus 1. Now divide both sides by 3. So x equals log base 2 of 9, then a minus 1. That's all over 3. Cool, we've solved for x here. Now just a couple comments are in order about this. Just the thing we said, first of all, that log base 2 of 9 minus 1 is not the same as log base 2 of 9 minus 1. Okay, log base 2 of 8 is different than log base 2 of 9, then a minus 1. Okay, so be careful with that. To write log base 2 of 9 electronically, we're not going to spend a lot of time talking about this right now, but just type in ln of 9 over ln of 2 instead, using the change of base formula. So we're not going to dig into the change of base formula a lot right now. I just want to mention log base b of c can turn into, using this new form, this other formula. We're not going to go through why it's true, but the change of base formula says that log base b of c can turn into log base a of c over log base a of b. You'll notice that the left side of this formula doesn't even mention a, so on the right side mentions a twice. And I know this sounds weird, but it's like you just pick for a whatever number you want. So if we picked a both here and there to be e, then it's log base e of 9 over log base e of 2, which could be rewritten just ln of 9 over ln of 2. Okay, so log base 2 of 9, the 2 is like the b, the 9 is the c, turns into ln of 9 over ln of 2 using this change of base formula. It's just this, the point is just log base 2 of 9 turns into ln of 9 over ln of 2. So you could literally type in like an L and then a 9, sorry, an L and then an N and then a 9 in parentheses, slash, and then an L and then an N and then a 2 in parentheses. Now, sometimes I should just mention that, still looking at this log base 2 of 9. Sometimes log base 2 of 9 is written without parentheses. Books often do this. You'll see like log base 2 of 9 without the parentheses around the 9. But still, the appropriate thing to do, to be honest, for good practice is to put parentheses around. But because the book doesn't always do that, I should just mention it, right? So even without parentheses, even this thing right here, it should still be said log base 2 of 9. There's still a function, which is why the parentheses really should be there. There's no multiplication going on. It's not log 2 times 9. That's not correct. There's no times. It's not correct to say times because there's no times going on. So log base 2 of 9 even without the parentheses written. Now, one last thing. Do we need to check our solution? We've been talking about checking. The thing is, the original equation here, 2 to the 3x plus 1 is equal to 9. There was no logs up there, so we don't have to check that the input to a log is positive because there's no input to a log to check in the original. Okay, again, we just earlier there was this technique that we were applying that hasn't been applying in the problems we've just been looking at. That if you have a single log on each side of the same base, you get to set the inputs equal. And we saw, in fact, a moment ago in the previous part that technique is useful when solving this equation. Log base 3 of 4 minus x squared equals log base 3 of negative 2x squared plus 3x plus 8. In fact, we solved this equation earlier. We turned that into just set the inputs equal, without drawing a slash to the logs. Right? Set the inputs equal. So 4 minus x squared is equal to negative 2x squared plus 3x plus 8. Okay, this is a technique that's useful when you have a single log on each side of the same base. Right? To use the technique, needed a single log on each side. But what do you do if we're asked to solve log base 3 of x squared plus 5x equals log base 3 of x plus 2, then plus log base 3 of x minus 6? The technique we have at the top is no good because we need a single log on each side. Right? We can't use the technique we've been using because there's two logs on the right side. What do we do then? Well, next time we'll discuss these things called the laws of logarithms, and that'll give us a way to rewrite this right side here, the right side which has two logs. There's going to be a way to repackage that and write that as a single log instead. But that's for next time.